Howdy, apes. So, I'm not dead. I'm here at home trying to recover from COVID, and it's taking a little longer than I expected. So, thank you for hanging in there with me. Thank you so much, wonderful substitute, or if you're over there, thank you so much. And we are going to try to keep rolling with things. Hopefully, I'm going to be back in the actual classroom tomorrow, but I wanted to keep on going with the things that we are scheduled for our calendar. So you should have finished your article on where energy comes from in your state. If you were still having trouble finding that article for free, please Google New York Times, where does your state get its energy? Okay, just Google the title of the article and you should be able to come up with a copy of the article. It may not be the 2020 version, but the 2018 version will be just fine for our purposes. Okay, so today we are going to be taking notes with energy diagrams on non-renewable resources. So you should have gotten diagrams that look like this. Okay, one is a coal power plant, one is a nuclear power plant, and one is a diagram of hydraulic fracturing or fracking. Okay, so we're going to get through these three today, and I'm going to hide my face after this and just put the diagrams up on the board, and we're going to get through all three of these today. So all you need is that out on your desk and a pencil or pen, and just follow along, write what I write, draw what I draw, and we'll get through this. Okay, so here we go. I'm going to try to hide myself. Come on, computer. Okay, so I can still see myself down in the corner, but if you can't, then I know that it's working. I'm going to put my my computer down flat so that I can draw. If you see my ceiling fan, I'm so sorry, but hopefully this works. All right, so energy diagrams. Basically what we're going to do with this is talk about how energy is generated at different kinds of power plants. And we're looking at non-renewable energy today, okay? So fossil fuels and any type of non-renewable resources. So we're going to start with coal, all right? And we're just going to start from the left-hand side right over here, okay? Right over here, and we're going to take it to the right, all right? So we're going to do some labeling and some coloring in. All right, so right over here, this is our starting point, and we put coal in right here, okay? So the coal goes in right in here, and so go ahead and fill something in right in here. That's going to be our coal, our non-renewable resource. All right. Now, down here, it also says natural gas and oil power plants. So down here, this means we could also do this same process with natural gas or oil. So we're going to use coal as an example today with this whole process. But please do remember that this could also be a natural gas power plant. This could be an oil plant, okay, to generate electricity. So That's just something to remember. But coal, we use coal for a lot of our residential electricity, and so this is a really good example for us. All right, so our coal goes into this big chamber right here. All right, so it's going to fall down to the bottom, okay, and accumulate up on the bottom. All right, and this is where we have a lot of fire. All right, oh my goodness, this is not looking like fire. Yes, please laugh at me, okay? So this is supposed to be fire. Draw fire, but also label it combustion, okay? So somewhere in here, I would probably write it down here, combustion. Combustion occurs in this chamber, all right? Combustion. All right, so it's going to get really hot in here. Really, really hot. So hot that it's going to heat up anything else that's inside this area. Anything else. So, we're also going to have an extra pipe in this area. Connects down to this one, but the big important part is that it is kind of curly around and it connects to this next area, okay? So inside this pipe, we have water, H2O. And what happens when water gets hot? Well, it boils, okay? So H2O boiled. Whoop. Y'all are going to see lots of interesting handwriting from me today. All sorts of stuff. Okay, so our water gets boiled. It's really hot. Our water gets boiled. All sorts of stuff. Oh, but we also have this right here, okay? Sticking up out of our combustion chamber, all right? This is a smokestack, okay? So make sure that you write smokestack. And out of this, a big cloud, okay? That big cloud is air pollution. And we're going to put lots of different things in there that we're going to study in Unit 7. So, air pollution, that can include carbon dioxide, CO2, PM. PM is particulate matter, like ash or soot, all sorts of stuff that's solid, but it's really, really tiny, and so it could be breathed in. SO2, sulfur dioxide, CO, carbon monoxide, poisonous. Okay, so all of that comes from coal combustion, and it gets put straight up into the air. All right, let's come back down to our boiling water. So our water is inside this pipe and it's getting boiled. All right, comes over through to this next chamber. In this next chamber is a turbine. Okay, turbines are kind of hard to draw. So we're going to draw something that looks kind of like a funnel, and it's got a curly Q inside of it. All right, so it's something that's spinning. All right, we've got something that's going to spin. And how's it going to spin? Because the steam, the water that has changed phase into steam, turns the turbine. Okay? So we're going to write here, steam turns turbine. Right? Steam turns turbine. That happens right in here. Okay. That's not the only thing that we need to happen. This turbine is connected to one more mechanism, and that is the generator. It's right here, generator. Okay? All right. So the generator is generating electricity from the turns of the turbine, which are being turned mechanically by the steam. All right. So then the generator starts electron flow. So what I usually do is put little negative signs showing electron flow all the way up to this box. So negative signs for electrons, that's your electron flow. This box right here is your transformer. Which is going to distribute the electricity that's been generated to all of your different homes and businesses. All right, we'll put that over here. Okay, so we've gotten all the way over to the right-hand side, but we're not done yet because we've got a whole bunch of stuff down here at the bottom. Okay, so let's come back over to the bottom of our combustion chamber. Okay, we've got this pipe that's coming down off of the bottom. It's actually connected to our water pipe up here that is being heated up by that burning flame, that horrible looking flame. Okay, so that water, and yes, that pipe is filled with water. Okay, we'll mark H2O, is going to come up through here and be combined with any kind of steam from the turbine. Okay? So all of that is going to join up, and they're going to go over here to the right to this large container, which is a cooling tower. That's going to allow that hot water or hot steam to cool off before it gets dumped into a body of water outside of your power plant, so that it can be reused and put back into the environment. Okay, so this is usually called a cooling pond. And a lot of times when it's put into the cooling pond, it's still not as cool as the rest of the ecosystem, but it's cool enough. It's not as burning hot as it was back in the power plant. Okay, so cooling pond, things you should know about that. This is a body of water. Like an ocean, lake, or river, it can cause thermal pollution. Okay, so think about that. Thermal pollution. If you take a natural pond, okay, and you all of a sudden dump a whole lot of superheated water into it, what's that going to do to the rest of the ecosystem? Or specifically that spot that you dumped the superheated water, okay? It's going to shock the system, all right? And anything that's not used to that temperature water is going to have a hard time adjusting to it. You may have mass die-off, okay? And you have certain organisms that have a specific range of tolerance. Sometimes oxygen cannot be dissolved in certain temperatures of water. So if you have a lower oxygen tolerance, then you're not going to have those organisms that are going to be able to survive there anyways, right? So that's something to think about too. All right, so one more thing that we should write down, the transfer of energy between all of this, okay? So last thing, right over here on the right-hand side, okay? I want you to know the different types of energy. So we've got kinetic energy, okay? Kinetic energy in the steam, that causes the turbine blades to spin. And then that gets converted to mechanical energy. In the spinning of the blades, because the kinetic energy is the molecules moving around all the time, okay? Mechanical energy is the actual spinning of the blades, and then you've got electrical energy. In generators. All right. Okay, so pause if you need to make sure that you have all of this. And then we are going to go on to, let's see, do I want to do nuclear next? Let's go ahead and do nuclear next. Sure. All right. Let's go. Nuclear power plant. All right, so nuclear power is, I'm so sorry. Oh, sorry about that, y'all. Nuclear power is from non-renewable energy because we are getting energy from uranium, which has to be mined. And uranium is non-renewable. We are trying to find more sources of uranium, but since we have to mine it, there's a finite amount of it. So we are going to go again from left to right. And there's not as much writing on here, just basically labeling, and I'll be talking. All right, so right here, sorry, I'm having trouble with my throat. This big shell is the reactor. Okay? It has a thick concrete shell. And this is to make sure that radiation does not leak. Accidents usually occur in the reactor. Okay, that is important to remember. All right, so this is the reactor core. And in the core, we have fuel rods that are made of uranium. They look kind of like this. All right, so this is uranium 235 fuel rods. All right. So these fuel rods can be raised or lowered, and there's a control rod that can move itself in between these rods so that the reaction does not occur. When the control rod is in between the uranium fuel rods, then it prevents any kind of reaction happening between these uranium-235. Okay, when it is lowered, then you can have neutrons freely passing in between the uranium-235 fuel rods, and that's when the reaction actually occurs. All right, we'll talk more about that a little bit later. Okay, so in here you have water. Okay, and water is circulated all the time through the core. Okay, all the time. So when this reaction is occurring in the fuel rods, an immense amount of heat is given off. I mean, a huge amount of heat. So when water comes through to the core, it's heated up by the fuel rods. So this time we don't have fire, we have the heat coming off of the energy produced by this reaction that's occurring. So when it comes out of the core, it's super heated, and it goes up through these pipes here, and at this point it is steam. All right, steam, steam. All right, so in this chamber, this is your turbine. Just like the turbine in the coal power plant, just like it. It's the same thing, okay? So turbine, and so that means what's in here? Generator. Okay, so the steam goes through here, turns the turbine, and the turbine will then go to the generator, generate electricity. All right, steam. Oh, and then you've got a transformer connected to the generator, which will then transmit all of the electricity to everybody that needs it. Okay, so now steam in the turbine chamber will then go down to the point where we need it to cool off. So this chamber is a condenser. Okay, so condense, what are we doing here? We're turning steam to water again, okay? Changing that phase. So in essence, it can go back straight into here, into our water chamber, and goes through the process again, okay? But sometimes it will go over here into our cooling tower, when it has been recycled too many times, and then eventually into our cooling pond. Okay, our cooling pond has the same problems as our cooling pond in a coal-fired power plant. So this is our body of water. And it has the problem of thermal pollution. Okay, now cooling tower. One thing I wanted to point out with cooling towers, guys. So you see these, they have these concave sides with at nuclear power plants, at coal-fired power plants. These are different from smokestacks, okay? At the coal-fired power plant, smokestacks that put off air pollution are skinny, okay? They're super skinny. They look like this, okay? Oh, drawing is bad for me today, okay? And they're going to put off something that usually has a color, okay? It's going to be brown or gray. It has a color, all right? Cooling towers instead put off a usually white cloud, and it is non-radioactive water vapor. Okay, so not saying that everything that comes out of a power plant is like this, but these towers that have those concave sides and everything, if you see a whole bunch of those just pumping out, you know, all these clouds, that's what that is. It's the other skinny stacks that you should be pointing to for the air pollution, okay? That's what I wanted to point out there. Okay, in terms of energy conversion, all right? So write this down for your energy conversion. You're going from thermal energy to, so see, thermal energy, you're heating something up, okay? And then you're going to mechanical energy. Okay, where you're turning the turbine. And then electrical energy. All right, we're generating electricity. All right. Pausing for a second so that you can get this. Pause the video if you need to. We've got one more to go. All right, here we go. Okay, the geology of fracking. Okay, so fracking is hydraulic fracturing. this, whoop, there we go. Didn't mean to have you see what's going on my computer. Okay, so this is looking at different types of layers in the earth. And I wanted to give you an idea of what happens when we look for natural gas. So if you want to put up in the corner here, we are talking about natural gas. Okay. All right. So over on the right-hand side, okay, you see a traditional oil and gas wells, okay? So this is what happens when, this is what happens when you have layers that are porous and permeable. Hopefully you remember those words, okay? So I'm going to say that. We got layers are porous and permeable. Okay, now over on the right-hand side, this is a modern well with fracking techniques, and this is going to be used in impermeable material, okay? Impermeable material. So if you remember, porous and permeable, that means that you have holes in between the grains of rock, okay? So oil and natural gas can not only be trapped in there, it can also flow. So they could drill down in here, okay, into this rock, and then they can suck it up like a straw, okay? If they were to drill into this rock, this is impermeable. So this is like a clay. There's going to be some natural gas in here, but if they try to suck it up, it's not going to move. All right? There's no way for it to get into here. So that's why they have to use a new technique. So I'm going to label these layers. Topsoil is up at the top. That makes sense. All right. The next layer is going to be a aquifer layer. So this is going to be usable water. All right. Then the next layer is overlying sedimentary rock. Okay. Next layer, porous but impermeable shale. Okay? It will not let oil and gas move through. Okay, next, porous and permeable sandstone. And then this one is impermeable shale. Okay, but it is gas rich. All right. So we call this our source, rock. All right. This is our reservoir rock. So this, the last layer, the impermeable shale, is where all of our natural gas and our oil and everything, all of our organics, that's where everything's coming from. Source. Okay? It's moving up. The reservoir rock is where everything is staying. All right? So that's where everything is stopped, and that's where it's being held. So it's our reservoir. It's where we drill into and we suck it up. All right. This is a layer of oil. All right. Right here. And this is a layer of natural gas. So these two layers right here are inside this reservoir rock. All right. They both are lighter and move toward the top of the layer. Okay. So they're moving toward the top. Now, why did they not move through this shale right here? They moved toward the top of the sandstone because it's porous and permeable, okay? But then they stopped. Why didn't they move through the shale? Because of this word impermeable. There you go. It will not let oil and gas move through, okay? So we find this little lens right here. We go, oh, hey, look at that. It's like a bubble of money, basically, okay? And drill down into it and suck it all up. That's what oil and gas people have been looking for years. They know this sequence of layers. They know to find something that is porous and permeable, that is like this, and then that's followed by something that's impermeable, and then look for this bubble. Drill down in there, and then suck it up with a straw, called an oil well. All right? So when we stop finding as many of these, then we've got to find something new to be able to get all of the rest of this that's in impermeable rock. So that's where fracking comes in. I want you to know how it's done, and then we're going to talk about the environmental consequences when I come back tomorrow and the next few days. So, almost done. Oh, okay, so down, we drill a pipe down into the source rock, this impermeable shale, and pump water and or chemicals to fracture the shale. Okay, so the water goes down and is pressurized. Okay, then as it goes down here and they increase the pressure, then that what we're trying to do is make this rock permeable. We want spaces to connect in those grains, all right? So we need cracks so that the oil and gas can travel through those cracks to this pipe, and then we can suck it up, So we're making multiple cracks through increased pressure with water and chemicals. And all of those cracks are connected to this pipe. And that will allow those organics, the oil and the natural gas, to travel to the pipe and go where we want it to go, up to us. All right? So the oil or gas is going to be released, travel on up, and the cracks stay. All right? So I want you to think about, what are the consequences of something like this? And please don't think about things that you might have heard elsewhere. I want you to think about what I just told you right now, of this, the process of this, and how could that, the process that of pressurizing water, pumping chemicals down, and fracturing the rock that would otherwise not be fractured. What are some environmental or ecological consequences of that? And what do you think of that kind of a process? Okay, so that's what I'm going to leave you on. We're done with our doodle notes, and I appreciate y'all sitting through this today. Let's see. Can I get this back? All right, there we go. So I should be back tomorrow. We have a reading quiz, so be prepared for that. And if you have started a quick study card just on a piece of paper or something, that's perfectly fine. I will get something to you as soon as I'm in there. Thanks for hanging in there with me, guys. I appreciate you so much. I'll see you soon. Bye.